Hey guys, I want to do a quick video about bouncing and impulse equals change in momentum, or force times time equals change in mass times velocity. So the big idea is right here. The big idea is the impulse, or force times time, required to bring an object to a stop and then to throw it back again is greater than the impulse required merely to bring the object to a stop. So let's say that we have two Hillers basketball players, and let's say that this guy here is going to give a chest pass to this guy. All right, so he throws the ball and the ball's moving. So as the ball's moving towards this guy's got to apply an impulse, or a force times time, to bring the object to a stop, and that would change its momentum to 0. But then if this guy decides to throw the ball back again, it would require an additional force times time, or additional change of momentum. So it's more. So if he just has to bring it to a stop and then throw it back again, that's more than just bringing it to a stop. Here, let's do a problem. All right. So let's say that we have a Hillers basketball player, all right, that's going to catch the 0.6 kilogram basketball, moving at 8 meters per second, and then has to pass it back at the same speed. What's the basketball's change in momentum? All right, so the first thing to look at here is the ball. All right, this ball here is moving in this direction. All right, and since the ball is moving in that direction, that ball has momentum, which is mass times velocity, or 0.6 kilograms times 8 meters per second. That equals 4.8 kilograms times meters per second. But he needs to actually bring that ball to 0, to a stop. All right, that ball's got to stop. All right, that would require an impulse, force times time, which is going to equal this. So it would require 4.8 newtons per second to stop the ball. And then he's got to throw it back. All right, it's got to go the other way. So it actually starts at 0, all right? And now it's getting tossed the other direction. Again, that would be the mass times velocity, or the momentum again, 0.6 times 8, 4.8 kilograms times meters per second, in the opposite direction. So it went from 4.8 to 0, and now 0 back to 4.8 in the opposite direction. So 4.8 plus 4.8 is 9.6 kilograms times meters per second. That's the answer. That's the change in momentum. Or if you want to think in terms of impulse, it would also require 9.6 newtons times seconds of impulse. So catching and tossing it back is just like bouncing off the wall. Now, to kind of sum this up, in summary, all right, here's the big idea, in summary, okay? If an object bounces, all right, versus just coming to a stop, if the object bounces, there is an overall greater change in velocity, because it was moving in this direction and now it's moving in the opposite direction. That would lead to a greater change in momentum. If it's the same mass, greater change in momentum, which would lead to a greater impulse, since change in momentum equals impulse, and therefore it would lead to a greater overall force. So hopefully that helps with bouncing, impulse, and change in momentum.